Getting a space station into orbit is brutally hard. You might think it's just about building a metal tube and shooting it up, but the reality is much more unforgiving. A single module has to hold air against a vacuum, regulate temperature while swinging between burning sunlight and freezing darkness, and protect humans from radiation that would kill them on Earth. Governments spend decades and billions of dollars to solve these problems. The International Space Station took more than 10 years and over 30 missions just to assemble. It cost billions every year just to keep the lights on. That is the barrier. That is why, for 50 years, space stations were the exclusive playground of superpowers. But that era is ending. A startup based in Long Beach, California, is about to prove that a private company can build, launch, and operate a space station without the government safety net. Vast Space isn't just tinkering with blueprints. They are building Haven 1. It is a single module station designed to fit inside a Falcon 9 rocket and launch fully assembled. It is set to go up no earlier than May 2026. This isn't a paper project. The hardware is being welded, tested, and prepped right now. If they succeed, they won't just launch a station. They will break the monopoly on who gets to live in orbit. The problem with private stations has always been complexity. Most designs try to be too big, too fast. They want to launch massive structures that require multiple flights to assemble. That introduces risk. Every launch is a chance for failure. Every docking maneuver is a chance for a crash. Vast looked at the physics and took a different approach. Instead of building a giant puzzle in space, they built a station that works right out of the box. Haven 1 is about the size of a bus. It launches in one piece. Once it reaches orbit, it wakes up, deploys its solar panels, and it is ready for humans. That sounds simple, but the engineering behind it is intense. The station weighs roughly 14,000 kilograms dry, and when fully loaded with supplies, it pushes closer to the limits of what a rocket can lift. This brings us to the first major hurdle, the launch vehicle. The Falcon 9 is the workhorse of the modern space industry. It launches satellites and Dragon capsules every week. But launching a fully outfitted space station is different. The rocket has to lift the station, the docking systems, the life support, and the consumables all at once. Engineers had to calculate every kilogram, every bolt, every panel, every liter of water had to justify its weight. If the station is too heavy, the rocket can't get it to the right orbit. If it's too light, the walls might be too thin to stop micrometeoroids. It is a constant trade-off between safety and physics. Vast used high-grade aluminum alloys to keep the structure strong but light. They ran hundreds of simulations to find the perfect balance. This is technical mastery in action. They didn't invent new physics, they just optimized the engineering better than anyone else. Once the station is in orbit, the next challenge begins. A station is useless if you can't get people to it. Docking is one of the most dangerous maneuvers in spaceflight. Two objects moving at 27,000 kilometers per hour have to touch gently and seal airtight. Commercial spacecraft have struggled with this. Sensors fail, thrusters fire a millisecond too late. The margin for error is less than the width of a coin. Vast didn't try to reinvent the wheel here. They partnered with SpaceX to use the Crew Dragon vehicle. This was a strategic move. Crew Dragon is already proven. It has carried astronauts to the ISS multiple times. By designing Haven 1 to work specifically with Dragon, Vast removed a huge chunk of risk. They didn't need to build their own taxi, they just needed to build the destination. When the first crew launches, they will ride in a vehicle they trust to a station designed to receive it. That is resource efficiency quantified. Instead of spending billions developing a new capsule, they focused all their capital on the habitat. Life inside Haven 1 will be different from the ISS. The station is small, with about 45 cubic meters of living space. That is roughly the volume of a large van or a very small room. 4 astronauts will live there for up to 30 days. This short duration is intentional. Living in microgravity destroys the human body over time. Bones weaken, muscles shrink, and eyes change shape. On the ISS, astronauts stay for 6 months and have to exercise 2 hours a day just to minimize the damage. VAST is targeting a different kind of mission. By keeping stays to 30 days, they reduce the medical risks. They also simplify the life support systems. A system that needs to run for 30 days is different from one that needs to run for 20 years. It can be lighter, simpler, and easier to maintain. This allows them to focus on the science and the experience rather than just survival. The interior is organized with a precision that makes a submarine look cluttered. Every item has a specific place in a drawer system. Nothing floats loose. This attention to detail extends to the supplies. Oxygen, water, and food are consumables. They take up space and add weight. VAST engineers calculated exactly how much 4 people need for 30 days, plus a safety margin. They didn't pack for a year, they packed for the mission. This reduces the launch mass and saves money. It is the difference between packing for a weekend trip and moving your entire house. One is efficient, the other is a logistical nightmare. But the real game changer isn't just the air they breathe, it's the data they send. You have felt the frustration of slow internet. Now imagine trying to run a modern research lab with a connection slower than 1990s dial-up. That is the reality for much of the space industry. Data moves slowly. Video calls lag. Real-time collaboration is painful. VAST decided to fix this by integrating Starlink directly into the station. This is a massive technical leap. Starlink satellites orbit Earth at fantastic speeds. Haven 1 is also orbiting at fantastic speeds. To get a signal, the station has to point a laser terminal at a passing satellite, lock on, and hold that connection while both objects are screaming across the sky. The precision required is like shooting a bullet with another bullet from miles away. And they have to do it continuously, handing off the signal from one satellite to the next without dropping the connection. When they pull this off, the result is gigabit speed internet in orbit. That changes everything for researchers. Instead of saving data to a hard drive and waiting for the capsule to return to Earth, they can stream it down in real time. Scientists on the ground can watch the experiment happen and tell the astronauts to adjust a setting instantly. It turns the station into a remote extension of a lab on Earth. It also means the crew can video call their families without the awkward delay. That human connection matters more than you think when you are floating in a tin can hundreds of miles above the planet. Getting the hardware to work was a fight. Early tests of laser links in orbit showed how hard it is to keep a lock. Thermal expansion, metal swelling in the heat of the sun, could warp the mounting brackets enough to throw the laser off target. Engineers had to design mounts that stay perfectly rigid even when the temperature swings by hundreds of degrees. They built software that predicts exactly where the next satellite will be, so the laser is waiting for it. This is the kind of hidden engineering that separates a PowerPoint presentation from a working spacecraft. The competition is watching this closely. China has its Tiangong station. It is large, government-run, and fully operational. NASA has the ISS, but it is aging and set to retire around 2030. There is a looming gap. If private stations aren't ready by then, the US and its allies will have nowhere to go in low Earth orbit. VAST is racing to fill that gap before it opens. They aren't waiting for a government contract to start. They are building now to be ready when the need becomes desperate. This pressure puts a spotlight on the human element. You can't just send random people to a space station, they need to be trained. But standard astronaut training takes years. Commercial customers don't have years. VAST had to compress that timeline without cutting safety. They brought in veterans like Drew Fustel, an astronaut who has spent over 200 days in space and fixed the Hubble telescope. He knows exactly what can kill you up there. Fustel helped design a training program that turns civilians into competent operators in months, not years. They spend hundreds of hours in simulators that replicate the Crew Dragon cockpit and the Haven 1 interior. They practice docking, emergency drills, and daily operations until it becomes muscle memory. They fly parabolic flights to get a taste of zero gravity. learning how to move without smashing into the walls. One critical part of training is handling emergencies. What happens if a fire starts? What happens if the pressure drops? In the simulator, instructors throw every possible disaster at the crew. They fail, they learn, and they try again. By the time they strap into the rocket, they have faced death a dozen times in the safety of a computer lab. This builds a competence hierarchy. The person who knows the systems best leads the way. It's not about rank, it's about survival. This training also revealed small design flaws that engineers fixed before the hardware left the ground. In one simulation, a crew member struggled to reach an emergency valve while strapped into a restraint. The engineers moved the valve. In another, a display was hard to read during the vibration of launch. They redesigned the interface. These feedback loops are faster in a private company. They don't need a committee meeting to move a switch, they just move it. The first mission, called VAST-1, will be the proof. 4 people will launch on a Falcon 9, dock with Haven 1, and live there for up to 30 days. They will run experiments, test the Starlink connection, and prove that the life support holds up. If they succeed, they open the door for everything that comes next. And what comes next is ambitious. Haven 1 is just the beginning. It is a test bed. VAST's long-term goal is to solve the problem of gravity itself. We know that zero gravity is bad for humans. If we want to live in space permanently, we need artificial gravity. The only way to get that is by spinning. VAST plans to build larger stations that rotate, using centrifugal force to push the crew against the outer walls, mimicking the pull of Earth. Haven 1 will conduct the first experiments to lead to this. They plan to use the station to test how fluids and mechanisms behave under different rotation speeds. It is a stepping stone. You build the simple station first to prove you can keep people alive. Then you build the complex one to prove you can keep them healthy. This leads to the roadmap for Haven 2. This isn't just a bigger version of the first station. It is designed to be a permanent orbital laboratory. It aims to replace the ISS. The plan calls for a station built of modules that are 5 meters longer than Haven 1. It will support a larger crew, 8 people at a time, and run continuously. The modularity is the key breakthrough here. Instead of launching the whole thing at once, they launch it in pieces. Each piece docks to the others, growing the station over time. This is how the ISS was built, but Haven 2 uses modern technology to do it cheaper and faster. The modules are designed to fit inside the payload fairing of SpaceX's heavy rockets, maximizing the volume they can send up in a single shot. Haven 2 targets a launch of its first module by 2028. By 2032, they want the full station operational. That timeline is aggressive. It relies on everything going right with Haven 1. It relies on the Falcon 9 and potentially Starship being available and reliable. But the scoreboard shows that the commercial sector is hitting its marks. SpaceX launched nearly 100 times in a single year. The cadence is there. The lift capacity is there. Now the destination needs to be there. The financial efficiency of this approach is stark. The ISS cost $150 billion. A commercial station like Haven 1 costs a fraction of that. We are talking about hundreds of millions, not tens of billions. That difference means more players can enter the game. Universities can afford to send experiments. Smaller nations can afford to send astronauts. It democratizes access to orbit. But let's not pretend the risk is gone. Space is still dangerous. A micrometeoroid traveling at orbital velocity packs the energy of a hand grenade. A solar flare can fry electronics. A seal failure can empty the station of air in minutes. VAST has built redundancies for all of this. The hull is shielded. The computers are hardened. The air supply has backups. But the risk is never zero. That is why the first crewed mission is such a pivotal moment. It is the transition from theory to reality. Thousands of hours of engineering, testing, and training come down to that launch window. When the engines light, there is no more fixing it. It has to work. The success of Haven 1 would force a shift in the global space industry. Right now, China is the only nation with a growing independent station program. Russia's program is aging. The US and Europe are relying on the private sector to step up. If VAST succeeds, it validates that strategy. It proves that you don't need a government agency to build infrastructure in space. You just need a solid business plan and excellent engineering. Think about the implications for manufacturing. There are materials, fiber optics, pharmaceuticals, specialized crystals that can only be made perfectly in zero gravity. On Earth, gravity causes defects. In space, the structures form perfectly. For years, this was just a neat science experiment. With a commercial station, it becomes a business. Companies can rent time on Haven 1 to produce these materials. If they can make a product that is 10 times better than the Earth-made version, the high cost of launch becomes irrelevant. The profit margin justifies the trip. This is the strategic future positioning that investors are looking at. It's not just about tourism, it's about industrializing low Earth orbit. Haven 1 provides the platform, Starlink provides the data pipe, Falcon 9 provides the truck. All the pieces are finally in place. The pattern recognition here is strong. We saw it with satellites. First, only governments had them. Then, commercial companies started launching them for TV and communications. Now, private satellites dominate the sky. We saw it with launch vehicles. SpaceX took over the market from state-backed rockets. Now, we are seeing it with stations. The transition from government to private control is the natural evolution of the industry. VAST is positioning itself to lead that transition. They have the hardware, they have the launch partner, they have the training program. The only thing left is to fly. When Haven 1 reaches orbit, it won't just be a metal can in the sky. It will be a proof of concept for the next century of human expansion. The gap between what was considered impossible 5 years ago and what is happening now is closing fast. We were told private companies couldn't build reliable rockets. They did. We were told they couldn't fly humans safely. They did. Now we are told they can't build space stations. VAST is about to answer that challenge. The countdown is ticking toward 2026. The hardware is coming together in Long Beach. The crews are training in simulators. The rockets are landing on drone ships. The pieces are all moving in the same direction. It is no longer a question of if a private station will succeed, but when. Haven 1 is ready to take that slot. The monopoly is over. The open market has arrived in orbit.